Alright, day number 3, we're going to start 7.2, division of exponents. So first thing I want you to do is I want you to copy down those two things inside of your journal, and I'm going to explain what those things go as we go throughout the lesson today. So, pause it, copy it. Okay, next thing I want you to do is we're going to start talking about how to divide exponents properly. I want that box right there copied down inside your journal. As you can see, when we divide exponents with the same exponent, yesterday and the day before, when we multiplied exponents with the same base, we added them. Today, when we divide exponents with the same base, we subtract them. Okay? Now, there's a couple things you have to know. Subtraction happens in the top of the fraction or the numerator. But c to the 11th over c to the 8th becomes c cubed. R to the 5th over r squared becomes r cubed. Okay, so let's go ahead and let's do a bunch of these kind of problems, and then we'll see where we get to today, or what I think is a good stopping point. So, if I have a to the 4th over a squared, that becomes, let me see if I knew it. I had a feeling this thing wasn't on. There we go. A to the 4th over a squared. When we subtract those, it becomes a to the 4th minus 2 or a squared. Okay, we're not dividing them, we're subtracting them. Likewise, if I have x to the 6th over x to the 4th, it becomes x to the 6th minus 4 or x squared. Okay, so a little bit harder one may be like x to the 7th y squared over x to the 5th y. When we subtract them, we only subtract things that have like bases. So we get x to the 7th minus 5, y to the 2 minus 1, or just x squared y would be our solution there. Okay, so when we divide exponents, we now are going to subtract them. Okay, so let's get to some problems here you're going to see that are kind of tough. We need to wait a sec before we go to that one. Okay. So if I have this 12BCD over 28CD. First thing you're going to have to do is you're going to have to reduce the fraction. So the first thing we're going to do is we're just going to look at the fraction and reduce it. Well, what number goes into 12 and 28 both? Well, 4 goes into it, so I know that fraction is going to reduce to 3/7. Now, we have a b up top. There's no b down low, so the b just stays there. C to the 1 minus 1 and d to the 1 minus 1, which gives us 3 over 7, b, c to the 0, t to the 0, d to the 0. Now, anything raised to 0 equals 1. So basically, those things are going to cancel, and your answer is just going to be 3/7 b would be your solution there, or 3b over 7, or 3b over 7 would be another way to write your answer. Both of those things are correct. Okay, so let's do another one of them. So if I had 40 BC over 48 ABC. Alright, so we have to reduce the fraction. So 40 over 48 becomes 5/6. The b's are going to cancel because 1 minus 1 is 0. So we know the b's are going to cancel and the c's. And there's just an a left over underneath. Okay, because when we subtract 1 minus 1, we get 0. So, okay. The next thing we have to talk about is when you have a power raised to a power. So just like before, when we had a problem like this, 5b over a to the 4th, and if this whole thing was cubed, if we had a power that was outside of the parentheses, remember what we did is we had to distribute it to everything inside of this thing that had an exponent. Now, not just the top, but it also comes down here to the bottom. So this is going to become 5 cubed. There's a 1 right here, and 1 times 3 is b to the third over a to the 12th. Or this thing reduces to 125. Can you guys see that even? So this thing reduces to 125b cubed over a to the 12th. And this cannot be reduced any farther because those are different bases. So even though there's an exponent up here, it also comes down here to the bottom. So let's do another one here. If we had negative 5b over w squared, and if we had this thing cubed, that 3 would go to everything inside of this that has an exponent. So negative 5 cubed, v cubed over w to the 6th, which is going to give us negative 125 v cubed over w to the 6th. Remember, a power raised to a power, you multiply them. Okay? Any questions on any of that? As if any of you guys could ask me questions. That'd be awkward if all of a sudden somebody did ask me a question. If I had 2xy squared and cubed over 3xy, and if I had this whole thing squared, this is the last one I'm going to do. So if I have this problem, that squared is going to go to everything inside of there that has an exponent. So 2 squared is 4. X to the 4th, y to the 6th, over 9x squared, y squared. Now, we're not done on this problem. The difference between this problem right here and this problem right here is these are not common bases, so we can't subtract them. But here we do have common bases. So what we're going to do is we're going to go 4 over 9, x to the 4th minus 2, y to the 6th minus 2, which is going to give us 4 over 9 x squared y to the 4th, and that would then be your answer, because subtraction happens on the top of the fraction. So, check out Alex, use the explanation button if you need it. There's a little brief introduction for you, and do we want to hit this last little bit here? Yeah, let's hit it. Okay, last little thing here. Anything raised to the 0 is 1. So like negative 7 raised to the 0 is 1. 3 raised to the 0 is 1. Mr. Glazier raised to a 0 is 1. Okay? The only difference is this. If I happen to have a negative out front like this, that becomes negative 1 because this negative is like negative times this. Okay, same thing if I have a negative 7 raised to the 0, that is negative 1. Okay, but anything else raised to a 0 is 1. I've seen some really hard problems in my time where I've seen problems like this, and I'm going to hope I can see this one on here. You may see a problem like this, 3x squared y cubed z to the 4th over negative 4x to the negative 3, y to the negative 7, z to the 4th, all raised to the 0. Guess what that answer is? 1. So anything raised to the 0 is 1, no matter how weird or how funky it may look. Thanks.